This video is going to help us go over the first 6 problems on our 10.1 homework assignment. So if you are struggling with any of those, be sure to watch this video and get some help here. So let's jump into number 1. So it tells us that the price of beans at a supermarket is shown in the table here. Excuse me. So we have the pounds here represented by P and then our total cost. So when we buy 0.8 of a pound, it's $2.40. When I buy 1.2 pounds, it's $3.36, 1.5, $4.50, and 0.6 pounds, so just a little bit over half a pound, is $1.80. So I'm noticing this chart isn't necessarily going in order, but it should be a constant rate. So to get from here to here, I would do the same thing every time. So we want to figure out what is that rate that's happening. So we want to write an equation for the total cost C. So our cost is C of pounds of green beans. So that's telling me an equation for the total. So this is going to be our answer. Our cost is the answer for pounds of green beans. So per pound. So my first step I would take would be to find the unit rate. I can take any of these ratios here and set it up. So I'm going to put pounds on top and the cost on the bottom. Again, it won't matter which one you do. I'm just setting it up like my graph already is. So I'm just going to take this first one here and say when I have 0.8 of a pound, that cost me $2.40. Now, I want to know when I have 1 full pound, 1 exact pound, what is the cost of that going to be? So I can see here that I can multiply those. So $2.40 times 1 pound is $2.40. And then I'm going to divide by 0.8. So now we need to remember to move our decimal. So we move our decimal here. So I should have 2 numbers in front of my decimal, or 2 places in front of my decimal. So 8 can't go into 2, but it can go into 24 3 times exactly. So if I did 24 here, I'd bring down my 0, and it goes in there 0 times. So I can see that every 1 pound, so every time I'm going to just add on to my table, if I buy 1 pound exactly, that is going to cost exactly $3. So now we want to come back and write an equation using C and P to show how could you find any cost in pounds here. So I know that, so P is what we're looking for here. And I know that it's $3 per pound. So when I do 3 and I times that by any amount of pounds of green beans that I buy, that is going to give me my total cost here. So if I had 5 pounds of green beans, 3 times 5, the total would be 15. I bought 2 pounds of green beans. 3 times 2 is 6 total. So this equation here can help me find any number on this table. I could say I want 0.75 pounds. 3 times 0.75 will give you the total cost here. So this equation will help us find anything on this table. So one thing I noticed in Ed is that when I just use my keyboard and I type in that 3 pounds, $3 per pound, so 3 P's, and then say equals C. And I'm just using my keyboard here, typing with my fingers using my keyboard. And that when I go to check that, it tells me that it's wrong. And I was like, what? Okay. So it's like, I know that's right. I have $3 per pound equals my cost. I was like, that's not making sense here. So one thing, if you'll notice, so let's try this again. So some things I can do here is if I can rewrite that. Okay, I could put C first. C equals the pounds. But I'm also noticing, right, it's a capital C and a lowercase p. So if you'll use these buttons on your screen here, that is going to give you the right answer. So I want 3 per pound. So 3 times P equals C. So same thing. And when I check that, oh, is it not going to let, oh, I've already been messing with this, but it should be right. So I ran out of checks because I have been playing with this to find out. I was like, I knew I was putting in the right answer, but it kept marking it wrong. So if you'll use the buttons on your screen, that is going to help you, that even if you put this in, it will be correct. So I know in my book here, I can see I want C first, but that's the same equation. It's just written a different way, but it means the same thing. I just always like to put the answer at the end because that just makes sense in my brain. But C equals 3P is the same thing. So use the buttons on your screen, even though I think it's more annoying than typing it. I like to type rather than click. But by using these, we make sure we're getting the right variables, and that is important. So be sure to use these as you are doing your ed problems. So number 2 says that joules and calories are 2 different units of energy. So the equation J for joules equals 0.239 calories. Groups of calories measures the unit. C for calories, J for joules. We want to complete this table. So we're just using this equation. So we can see here, every time it gave us C, we're looking for J. So I'll help you get started on this first one. So I can see I have 0.239, and I'm going to multiply by C. My first C is 3. So I'm going to plug in 3. 3 times 9 is 27. 9, 10, 11. 6 and 1 is 7. And I have 1, 2, 3 decimal places. 1, 2, 3. So this first number right here, I'll type in 0.717. So I'm going to let you finish this table using this equation here. So each time we know C, so plug in C and multiply, will tell you the conversion to joules here. Number 3, a car wash attendant counted the number of cars washed and the total amount of money earned. The company charges the same price for each car washed and earns $165 for 15 cars, $231 for 21 cars, and $275 for 25. So we can see this is all laid out in this chart here. And we want to find an equation for the money they earn and compare that to the cars washed. So we want M to be the answer. So N is our independent variable. So how many cars come? People can choose if they want their car washed or not. That's independent. But then it depends. So the money depends on how many cars come to get washed. So here's 15 cars. So remember, when we're writing these equations, we need to find that unit rate. So I'm going to put my numbers of cars washed on the top and compare that to my money. So when I have 15 cars, that equaled, wrong number there, I was looking at the wrong chart here. So I need to go down $165. And I want to know, when one car is washed, how much money is that, right? So I want to know the number of cars. I want to know that independent variable, this first one, as a 1. If one car comes to get washed, how much money will they make? So I'm looking for my money. So I would multiply here. 165 times 1 is 165. And then we're going to divide by 15. So 165 divided by, whoops, not N. Oh, whoa. Divided by 15. So I can see here, it goes in here one time. So I want you to go ahead and finish that problem and then come back and we'll look at your equation. So there's 15 and another 15 is 11. So every car they wash, so if they wash one car, that earns them $11. So if here's our N, and they'll get $11. So 11 N equals M. So 11 N equals the money they will earn. So if they wash two cars, they'll earn $22. They wash three cars, they'll earn $33. So this equation can help this car wash attendant figure out how much money they should have when the day is done. If they know how many cars have been washed, they times that by 11, they'll know how much money they made. So remember, as you're doing this, if you put in the numbers with the on-screen keypad, not with your keyboard. So click on the screen and you can type this in. You can put that M equals 11N or 11N equals N. They're the same thing. 11 N's is an M. So use that on-screen keyboard will help you put those in so that Ed likes your answer. Number 4 tells us that data for the fastest long-distance train in the United States as of 2018 are shown. T is the time in minutes. D is distance in miles. So the distance, the total the train can go is 2.5 every minute. So it travels 2.5 miles per minute. So every time it's been a minute, it went 2.5 miles. It's been another minute, 2.5 miles. So here is our problem here. So first we need to know what is dependent. So dependent is remember that's our answer. This is our dependent one is dependent on the time that we go. So the distance we travel is dependent on how long the train was going. So if the train goes for 3 minutes, what was the distance? Okay. So now let's use this equation to solve this. So we have D equals 2.5 T. So we just need to take each of these and plug it in where it goes. So here we have a T. So we'll start with 2.5 times 3 equals D. Well, D's already alone, so all I have to do is 2.5 multiplied by 3, and that will give me the distance the train can travel. So now I'm given the distance, so I'm going to plug in 15 for D, and it's always 2.5. That's the constant that it's doing every minute. But now this time we're looking for the time. The time is empty. So I want to get this T all by itself. So I'm going to divide here on both sides. So this one cancels out. So now I need to do 15 divided by 2.5. So we're going to move our decimal, which means moving our decimal here at the end. So we're going to think quarters and see how many times 25 can go into 150, and that will tell you how many minutes the train traveled. So you'll repeat that. So this time we'll plug in 10 for T, and then we'll plug in 28 for D. So when you're doing this one, we're dividing by 2.5, so you're going to have to move that decimal. The decimal's at the end, so that means adding on a 0 here. So go ahead and solve for each of those using this equation here. Number 5 wants us to write an equation to represent this. So we're using X and Y. So something we're doing to X is getting us to Y. So I'm noticing 17, 25, 14, 22, 29, 37. So there's nothing they're really counting by going this way. There's not a nice way to multiply to any of these. So let's look, how are they adding? Let's maybe see if adding gets us from X to Y. So here, 17 to 25, they're adding on, let's see, there's 3 to 20 and 5 more is 8. To get from 14 to 20 is 6, plus 2 more is 8. Okay, that's looking good. So adding 8, 29 plus 8 is 37. So I can see here, this time my pattern, they're taking X and they're going to add on 8 more, and that's going to equal Y. So first, let's think about some other ways we can write this same problem here. We can use the commutative property and flip the 8 and the X. And I can say I want 8 more than X is Y. This one says I have X, add on 8 is Y. We could also flip this completely around and say that Y minus X equals 8. I take 25 and minus 17. The answer is 8. We could also take Y, we can subtract 8, and that would give us X. So any of these are going to be equivalent equations. When you're putting it into Ed, you'll want to be sure and use the on-screen keyboard to get it in correctly with those variables as they've given them to you. Okay, and number 6, last one in this video, I'm going to go over, ask this again to write an equation to represent the values. So here, let's see, we've got 9 to 135, 12 to 180, 16 to 240. So I don't think they're adding because this is adding on 126. This is adding on 100 and, trying to do some math in my head, 68. So they're not adding the same thing. So that's not the pattern. So if they're not adding the same thing, they're not subtracting the same things. Those are opposites. So let's look into multiplying and dividing here. So I'm going to take 135 and divide it by 9. So why don't you go ahead and try that? So I know it doesn't go into 1, but it goes into 19 one time. And left over is 4. Bring down my 5. That goes in there 5 times. So I know to get from 9 to 35, we had to multiply by 15. We're going backwards. We divided by 15. So let's check out 180 and divide that by 12 to see if it's following the same pattern here. So I know 12 can go into 18 one time. So go ahead and finish that problem there. So there is 12. So there's 6 left over. And then yes, 12 does go in there 15 times. So it looks like our pattern every time is we're taking D and multiplying that by 15. But instead of saying D times 15, that is not our best way to write that, because now that looks like a variable. So remember, we want this coefficient. So 15D equals G. So we could write this in many different ways. We could say that G divided by 15 is D, G divided by D is, or G divided by 15 is D, G divided by D is, okay, I need to restart. I just need to write them down. I'm getting myself all confused. I could say G and I could divide by 15 and say that equals D. All of these sound too similar. I could take my total and I could divide it by D and that would give me 15. So any of these 3 equations will give me the values in this graph here. So go ahead and try those homework problems and finish up your homework. If you are having any questions, be sure to let me know and we can set up a time to meet together.